Well, they gave us the f function, and it is ridiculous, full of all these transcendental functions, and let's figure out the derivative, because they're asking for the slope of the line tangent to f at x equals pi over 2. In order to do this is another way of asking, you've seen this before, another way of asking, what is the slope? Another way of asking it is the derivative. So here we go, negative sine x plus, because cosine derivative of that is negative sine, derivative of sine would be cosine, so we have 2 cosines, and then the natural log, the derivative of that is 1 over x, and then I want to know the derivative at a specific value, so that would be plugging in a pi over 2. So negative sine of pi over 2 plus 2 times cosine of pi over 2, put parentheses there and there if we want to, plus 1 over pi over 2. Okay, it's going to get gross, but that's all right. Sine of pi over 2 is 1, so that makes this term negative 1. This is 0. Cosine of pi over 2 is 0. And then this term is 1 over pi over 2. So this denominator reciprocates, and so we have 2 over pi. So plus 2 over pi. We can leave our answer like that. Let's move on. What is the instantaneous rate of change? Again, I said it a minute ago, slope of the line tangent to instantaneous rate of change. It's all asking the same thing. Instantaneous rate of change for that function at that value. Well, let's do it. So y prime is equal to, well, I need the derivative of sine, which is cosine, but there are 4 of them. I need the derivative of cosine, which is negative sine. Now, hold this thought for a second. We have a negative sine times negative 8, so it's going to be plus 8. And we want to plug in 11 pi over 4. Okay, well, we don't want to plug in 11 pi over 4. And here's our knowledge of the unit circle kicking in a little bit here. Let's grab a different color pen. And so we have 11 pi over 4, which is really equal to, okay, well, 4 goes into 11 2 times. So we have 2 pi. And then we have a little bit extra. We have 3/4 left over. Well, this is one full circle. Let me try to slide that over so you can see it. This is one full circle, and this is what's left over. These two are equivalent. They take us to the same place on the unit circle. Okay, so here's our unit circle, and there's a full 2 pi, and then 3 pi over 4 left. It takes us here. That's where we are. So we are going to plug in 3 pi over 4. So y prime of 3 pi over 4, we can do that, equals 4 cosine of 3 pi over 4 plus 8 sine of 3 pi over 4, and we are going to figure this out. Cosine of 3 pi over 4, this coordinate is negative square root of 2 over 2, comma, positive square root of 2 over 2, and the cosine is the x value, so 4 times negative square root of 2 over 2, plus 8 times positive square root of 2 over 2, and that leaves us with, let's see, this 4 cancels with that 2, gives me negative 2 square root of 2, plus 4 square root of 2, which gives me 2 square root of 2. That's it. All right, that's the exact value of the instantaneous rate of change. Now it's asking the same question in a different way. Evaluate dy dx at x equals natural log of 12 for y equals 1/3 e to the x. Like, what? Okay, what? I need to know the derivative of this first. So you can call it y prime if you like. I'm not going to call it y prime. I'm going to call it dy dx, dy over dx. It's the same thing. You can say this is y prime. They're all the same. But they're using the Leibniz notation in this context, so that's what I'm going to do. So the derivative of 1/3 e to the x, well, the derivative of e to the x is e to the x, and we have a constant. Here's that constant multiple rule. So just put the 1/3 in the front. The function has its own derivative that is itself. It's really handy that way. And so now what we want to do is evaluate dy dx at a specific value. And this notation is going to look a little bit still kind of new for you. We're going to do a little vertical line here, a big vertical line, and say, well, all this is going to get evaluated at the natural log of 12. And so we're going to have 1/3 e to the natural log of 12, and there's some fancy canceling that's about to take place here. And e to the natural log in this configuration cancel each other out. This is 1/3 times 12, and there is a reason for that. There's an earlier lesson from very early. It's about exponents and logarithms. And so 1/3 times 12 is going to give me just 4. Okay, so now we get to the tricky one. So if f of x equals cosine x, then find the limit as x approaches pi over 2 of f of pi over 2 minus f of x over x minus pi over 2. What? Okay, this is the alternate form of a derivative. What are you talking about? Well, sort of the alternate form of a derivative. There's a catch to it. So way back, there is, turn right to it. This is great. Way back in some old notes, we had that. That's what this is. Here's what this question is asking. I'm telling you the function. Now I want you to evaluate the derivative at a specific value. Okay, let's compare. If f of x equals cosine, okay, great, good to know. Then find this thing that looks a lot like that thing. A couple exceptions, we'll talk about it. And evaluate this limit, x approaches pi over 2. They're asking you to evaluate, with an exception that we'll talk about, the value of the derivative at pi over 2. Okay, so that's what we're going to deal with. That's essentially it. But I also want to point out that what we see here is not what we just saw on that paper. I'm going to rearrange it and make them the same. This is equal to, there's a random period there now, the limit as x approaches pi over 2. Let's put this in the correct order. It should say f of x minus f of pi over 2 over x minus pi over 2. But I'm not allowed to just turn things around and say, hey, we're correct, we're good. No. What we just did technically was factor a -1 out of that numerator, and that gave us permission to turn subtraction around. Let's put a negative in the front. Okay, if that just flew very quickly, then here it is. Let's just shift gears on a scrap piece of paper for just a second. If I said, hey, look at this, we have 5 minus x, you'd say, okay, great, fine. But I said, I want that x to be first. Okay, great. We'll do that then. But then I say, I really don't like the way that looks. Let's factor out a -1. We would have this. It's the same idea. So this formula is more consistent with this formula. It's in order now. And in order to put it in order, we had to factor out a negative. I'll just put the negative in the front. It works. It's one of the properties of limits. It totally works. Okay, so let's recap. If f of x equals cosine, then find this. This question is saying, I'm going to rewrite it. I'm going to rewrite it in green. Find f prime of pi over 2. Oops, negative f prime of pi over 2. That's what this question is asking. There are going to be questions that are worded really funny, and you're going to have to pull in the recesses of your memory and say, what is this formula? This looks familiar. I've seen this. That's the form of a derivative, rearranged a little bit. And they gave you the function. Find the value of the derivative. Let's change the sign, though, for that reason. So I know that f is cosine, so f prime is negative sine. Therefore, f prime of pi over 2 is, well, let's see, negative sine of pi over 2. Okay, before we get carried away, they want us to find negative f prime of pi over 2. There we go. Sine of pi over 2 is 1.